Evaluating fairness and bias in AI models. When designing and deploying AI models, it is not only important to ensure their accuracy and performance, but also to evaluate the fairness and potential bias they may exhibit. Fairness is a critical consideration in AI systems, as biased models can perpetuate and exacerbate societal biases, leading to discriminatory outcomes. In this part of the course, we will explore how to evaluate fairness and bias in AI models, specifically focusing on explainability metrics. Before diving into the evaluation process, it is important to briefly understand what fairness and bias mean in the context of AI models. Fairness refers to the absence of any unjustified and discriminatory biases in the model's predictions or decisions. On the other hand, bias in AI models refers to the systematic favoritism or discrimination towards certain groups or characteristics. Evaluating fairness and bias helps us identify any potential issues and make necessary adjustments to ensure our models are fair and unbiased. To begin evaluating fairness and bias, we need to replicate the AI model's behavior. This can be done by using a dataset and the model's predictions on that dataset. It is crucial to have access to both the input data and the model's outputs to analyze and evaluate the model's fairness. Next, we need to choose appropriate metrics to evaluate the fairness and bias of our AI models. Some commonly used metrics include disparate impact. This metric measures whether the model's predictions are consistently different for different groups. It calculates the ratio of favorable outcomes between different groups and determines if there is a significant difference. Equalized odds. This metric assesses whether the modeled predictions are the same for different groups while maintaining accurate predictions. It evaluates if the model maintains similar true positive and false positive rates across different groups. Predictive parity. This metric examines whether the model predicts an outcome equally across different groups. It determines if the proportion of positive predictions is similar for different groups. False positive and false negative rates. These metrics measure the frequency of falsely classifying instances as positive or negative for different groups. It helps us understand if the model is biased towards false positives or false negatives for specific groups. Calibration. This metric evaluates if the model's predicted probabilities match its observed accuracy. It helps us determine if the model is well calibrated and providing accurate predictions across different groups. To evaluate fairness and bias, we need to prepare the data for analysis. This involves combining the model's predictions with the ground truth labels for each instance in the dataset. This labeled dataset will enable us to compare the model's predictions with the actual outcomes and evaluate fairness based on the selected metrics. Once the data is prepared, we can calculate the chosen fairness metrics to assess the model's bias. Analyzing the metrics for different demographic groups or other relevant attributes will help identify any potential fairness issues. By comparing the metrics across groups, we can identify if the model exhibits disparate impact, equalized odds, predictive parity, or other forms of unfairness. If the evaluation reveals fairness issues or biases in the model, it is important to take corrective actions. This may involve retraining the model with a more diverse and representative dataset, modifying the training process, or adjusting the decision threshold to achieve a fairer outcome. The understanding and evaluation of fairness and bias in AI models using explainability metrics can ensure that the models are fair and unbiased. Through careful evaluation and necessary adjustments, we can mitigate potential discrimination and promote the ethical use of AI systems. In conclusion, it's important to remember that evaluating fairness and bias is an ongoing process. Continuously monitoring and re-evaluating the model's behavior is essential to identify any emerging fairness issues over time and make necessary improvements.